a lot of people are asking me how do I get started with these boards, or they're not asking me and just working on random features. Um, it's very useful to do boards. So I'm going to show you how to do a board really quick, and we're probably going to find tons of bugs along the way. So this is the board that I found. It's some sparkfun board. This is actually Dope's board. So let's go into this. I'm going to run tsci in it. And usually it'll ask you to update. So I'm going to go ahead and update. So using the most up-to-date version is a really good idea. And then we're going to initialize our project. And I'm gonna literally be pointing out bugs as I do this because I already know there's a couple things that go wrong. So one bug here is it didn't use bun for my lock file. So I'm just going to reinstall using bun. And then I am going to run, you might want to run bun run start, but it doesn't configure that package file by default, which is fine. But, that's another small thing. Okay, let's run tsci dev. So you want to work through some of the bugs. Like ideally, you're not just tweaking UX all day. So a lot of people would stop there and they might start looking into those bugs because those sound easy. But Codex can do those bugs very quickly. So you should probably look for something a little bit harder. If you can muscle through it, you probably should. Okay, so we pulled up the server and we can see our little board. I'm going to create a new tab and I'm going to open cursor. And let's see what files we have. So we've got this index file. I'll save that. Okay, so resistor, capacitor, trace, great. So whenever you are building a board, the first thing you're going to want to do is find the schematic. And the schematic has basically all the information you need to create the board. And all you're going to do is create this. That's it. You want something that looks as close as possible to this. That is the most important first thing to do. Don't worry about the PCB. Don't worry about the footprints. Just create this board. I'm going to delete everything in here. I'm going to delete the width and height of the board. We don't care about any of that. Let's just get this schematic working. Usually people will look for the biggest chip first, not all these side things. There's actually only one chip that's like special here. It's this one, the color sensor, and it says opt 4048. Okay. So the first thing we're going to try to do is see if we can import this from somewhere like JLC PCB. And if I go over here, you can sometimes find some colors. It looks like the schematic usually has the part number, but anyway, we're going to look up that JLC PCB, see if they have it. Looks like they do. And if we scroll down, we can see if they have a footprint. They might not have a footprint. So let's go ahead and try the import. So there's a lot of ways to import parts. You can do it on tscircuit.com. We can also use the run frame GUI, type it in here, and then select import. And it says component not found. So maybe the error should be better there, but most likely this doesn't have a part. So there's a couple things we can do. One, we can manually create it. To manually create a part, what you'll usually do is you want to kind of use the sparkfun datasheet if you can, but you can look, these data sheets are open and available online, so you can use whatever. And if you scroll down, you'll usually see, and it looks crazy, but they all have this at the bottom. You'll usually see a land pattern or a footprint, and it'll usually have a name. So I guess in this case, its name is FC Scott or something like that. It looks like a soy gate pattern and or a small inline package 8. So you can always ask on Discord if you don't know. You just take a picture of this and say like, oh, hey, do we have this or whatever? If you go to the footprinter repo, you can try to find the footprint. So, well, actually, why are we even creating footprints? We don't even care about the footprint. Let's not worry about the footprint yet. We don't need to worry about the footprint. I don't know why I got so obsessed with that. We'll need it later, but we don't need it for now. But I guess it's good to note it. If you can import it, you get the footprint for free. So that's a nice thing. So anyway, let's create a file for this chip. I'm going to call it 4048.tsx. And then I will export. Oh boy. Yep, we're going to export that. And it's going to be a chip. And when you're defining a chip, if you look at anything that defines chips, you usually do this. You import chip props, circuit/props, like that. Okay, part 2. So we're defining this footprint on our left, and we're going to have a real-time preview as we do it over here. So let's set up my screen a little bit. We're going to have our real-time preview over here. This is what we're trying to create. So we're just making this chip, and we're making it from scratch with tscircuit. So I'm just going to set up the props for this. For props, they always kind of have this format where you want to give it your pin labels, and we're just going to copy those over. So normally in a sparkfun schematic, you'll see like pin 1 VDD or something like that. But in this case, they don't have any pin numbers here. So we actually have to use the datasheet to find the pin numbers. The pin numbers will be in this datasheet somewhere. And in fact, like, yeah, there they are. So pretty easy, right? Like, you don't have to read all this text. You just need to know how to look for these patterns. So there's all the things. And eventually AI will be good enough where we can just upload it. But for now, let's go ahead and do this. So VDD, pin 2 is ADDR, pin 3 is NC. I'm going to call it NC1 because there's 2 NCs. And NC actually means no connect. So if we want, we can just not define that. It means no connect. Do not connect. Pin 7 is int, which usually stands for interrupt. And pin 8 is SDA. Okay, so we don't need to know what these mean, but I'll explain it for fun. ADR is address, so something to set the address, a communication address. VDD is power. Ground is also part of power. It's where the electrons go out. And then you have SCL and SDA. This is clock and this is data. So there's almost always a clock and a data line for any chip you connect. Chips are basically just functions that you send data into. Okay, let's add a manufacturer part number, which we know is opt448. So now we're defining the chips. And defining chips is pretty AI can do a lot of this for you. But defining chips, there's a whole doc page on. So it's definitely worth just taking a read through and seeing all the ways you can define chips, all the ways you can customize the schematics. There are a lot of things you can do with chips. You can get very custom patterns, as you can see here. It's a pretty custom looking chip. So very easy to customize chips. It's worth having this doc up, or you can always use the AI context text file, which you can click on and get from the docs, and you can just ask Claude how to customize a chip. Okay. And so we're not far enough along where we can really find a bug yet. You know, you do have to play with it for a little while before you'll be able to find a bug. But so let's keep going on. I'm going to give the pin labels to this guy. And at this point, I think I want to see a preview of the chip. So I'm going to go to our index file. Whoops. I'm going to go to our index file and import our chip. Okay. Let's render it there, and it should show up. It says name is missing, so let's add the name. We probably have an error. So usually chips have the name you want. Okay, there it is. We can see it has no labels. Or probably what's going on is because we don't have a footprint, it doesn't know how many pins there are. So for now, I'm just going to give it SWIC 8 because it has 8 pins. And there we go. Top of 2. Let's see what that looks like. Okay, that's way too high. So we'll say 0.8. Usually makes sense to go in like 0.2 increments. Yeah, there we go. That looks about right. And then let's add something above SDA. I see there's also a little bit of margin there. So we'll add 0.2 there. Okay, there we go. So now we have a chip that looks just like our sparkfun schematic. And we can start filling this in. If we go to PCB, we have a footprint here, but it's not exactly the correct footprint. It might not physically place the same way. So we're going to fix that footprint later, and we can do that by customizing the footprinter string, or we can do that by importing. There's a lot of ways to fix a footprint, but the most important thing is the schematic. That defines how, that's what most people use to know how everything's connected. Okay, so I'm going to hop into the index file now. And usually the index file is where most of the connections are going to be. So you kind of define your components in other files, and then you save this file just for the connections. So I'm going to do VDD, and we're going to connect that to net v33. So all these net names are pretty hard to remember. You can see I deviated a little bit from what sparkfun did. So there's an easier way to do this. we're going to import cell from tscircuit core, or normally tscircuit, but the CLI is a little weird, and you have to import from tscircuit core right now. And then we actually get autocomplete when we use this. And this goes to the same string, but it's a lot easier to use because you have autocomplete. All the conventions are kind of baked in. So we'll do that for ground as well. And you can see in our schematic, we're starting to get the same labels. These aren't rendering with 90-degree angles, and that's a bug or a problem in core or the schematic layout. But so we don't have to manually fix that. You can with a net alias, but that's fine. That's basically equivalent. You don't need to fix that particular thing. Okay, part 4. We're still just wiring up the schematic. Everything should be a little bit easier now. We don't have to look at any data sheets. We can see we have a resistor R3 over there. So I'm going to give that resistor name R3, resistance 10K. And then we can see it has 2 connections. It has, let's say it's pin 1 that goes to this int net. So we'll say cell.net.int. So you can see it doesn't recognize this, and that's because we don't have autocomplete on everything. This shouldn't error, but unfortunately it currently does. And in the future, we want to have a way to do like this or something like that so that you can define these on the fly. But for now, you can ignore this, or you can just manually type in that net. So basically, it's not, we don't have types for that net. And then the other one is going to go to cell.net v3. Okay. So you can see we've got our resistor here, but it's not really in the right place. So let's, maybe I do this and this. So we're trying to create the top, and what we've got is the bottom. Okay. So let's move the resistor. So schematic auto layout will do this automatically, but that's not totally ready yet. It's technically merged, but it probably won't work for most cases. So let's just manually do it for now. So I tipped it 90 degrees and I moved it to the left, and you can see we have to move it up a little bit. So I'll move it up like that. Oh, it's a little too high. And you can also do this with manual edits, but I would just do everything in code because it's more predictable. For now, it's more predictable. You can see that these are actually connected with traces, which is kind of nice. It's nicer than net labels, but again, we need you really need schematic auto layout for that or something. So for now, we're going to be very lazy about it and just use a lot of net labels. So we're going to connect int up here to net.int, right? So these are equivalent, or basically equivalent. And we could use net alias to make this, but we're being lazy. We're not using net alias. We're just saying, hey, that's close enough. Hopefully people reviewing it can see that they're very close and there's not going to be a mistake. Let's see. Almost everything else is... So we've got this capacitor here, right? If you recognize the symbol for capacitor. Resistors and capacitors are 90% of the stuff. So 100 nanofarads is the same as 0.1 UF. So it's a little bit of a bug that we rewrite this. We should just take the user value if they pass in a string. If they pass in a number, we do want to automatically cast it. But in this case, we should have just taken the user value because that's a little confusing. You can see we're going to have to apply our schematic rotation again. So we'll do that. And then I'm going to actually spin it -90 because you usually want power on top. And it actually auto-completed wrong here. So then at that ground. There we go. Okay. And let's go ahead and move this. Just like the sparkfun one, we're going to move it to the left. A little bit more to the left. Okay, cool. So we've almost wired this up. We just need to do 2 more pins, but my doorbell rang.